RISC-V, you have heard a lot about RISC-V today and yesterday maybe. RISC-V offering CPU core IP. We are one of the large RISC-V companies. We are active already for 10 years. We have several products on the market. We have roughly 400 projects, 400 nominations, 400 products, 400 plus products which are on the market using our RISC-V core. But today we are just talking about automotive. So what is RISC-V doing in automotive? How strong is RISC-V already in automotive, and what are we going to deliver to you? What can you get from us in automotive? But let's start with a small other topic. What is our vision for automotive? What is it? It's very straightforward. Our vision for 2030 is you can build a complete car with only RISC-V. So every ECU, every product that's going into the EE architecture of an automobile can be based on RISC-V. This is our vision. 2030 is probably the best time. We guess there will be cars only based on RISC-V. This is our vision. This is what we are trying to achieve. Yeah. So how are we going to do that? What's needed? What can you expect from RISC-V to implement that vision, or that this vision becomes real? So every ECU, every computer in a car should be based on RISC-V. This is our vision. This is our target, and this is why we are here. Many people are talking about paradigm shifts in automotive. A big change in what's going on in automotive right now. Why are there suddenly so many opportunities? And really what is happening in automotive, and why are we saying there is a unique chance that RISC-V will become reality in automotive, with every ECU being based on RISC-V by 2030. What's the change? What's the paradigm shift? I don't know if you have been in China the last couple of maybe months, the last 1 or 2 years, then I recommend you look at this car. It's a very good car. It's the Xiaomi SU7. In Germany, it's called, competition to Porsche, but half the price. If you drive this car, it's really exciting. It's very good. It's very nice car. And it's very, very competitive. What is the change? What is the paradigm shift with this car? But it's not just Xiaomi. It's also Xiaopeng and another one. There is a new car introduced by Audi, which is also having a different, something is different, something is faster to market, it's a shorter time to market, it's a different product, where Audi is saying, Audi DNA, the old world meets the new world in China. What is it? What's really the paradigm shift? What's really changing, or what's different in these cars? What we see at this point is that the underlying EE architecture makes the difference. And that's nothing else than what the EE architecture, the ECU, the ADAS, the IVI, the zonal controller, the ECU is different. What is different in these architectures, and why do we believe there is a big change now going from the old world to the new world? A change that motivates us to say, look, this is a unique opportunity for RISC-V to enter this market. This is what we see. So the change, the underlying change we are seeing is that traditionally you had combustion engines, every ECU had a single function, and today we see a shift to what is called zonal and high-performance computer. So in the center of the car is a high-performance compute, and then you have a zonal architecture. The world simply moves to that. Now, when there is change, the good thing is change means we can change also the underlying architecture. It's a perfect change for RISC-V at this moment to move to automotive and to create a new underlying platform. So this is one of the key reasons why now is a good time. It's not tomorrow, it wasn't yesterday, it's now. We also believe, and that's for all the technical people here maybe the most important thing, we believe that a RISC-V EE architecture is better than a traditional one. A traditional one based on many different ISAs, many different architectures. It should be, and we are fully convinced of that, a single architecture. And what is better than RISC-V? On top of that, we as Sci5 follow the idea we want to introduce a portfolio for automotive that goes from entry to high end. So this is a key element here. So if you have the possibility to select an ECU in the entry segment and you can select an ECU in the high-end segment and it's all on the same architecture, that's where we want to be, and that's how we see at the moment the opportunity to drive the automotive market into a new direction. We also say, and that's from our perspective very important, RISC-V is ready to be deployed in automotive now. If you want to have a product by 2028, if you want to have a product by 2030, you can start now with RISC-V and you will have your product. The ecosystem is, from our perspective, ready enough to be deployed in a way that you can have your vehicle on the road latest by 2030. This is our key message. The ecosystem is available. Of course, there might be some gaps still, but 2030 is still 5+ years to go. But let me look a little bit deeper. Yeah, how are we implementing that? How are we evolving this architecture so that this vision, all RISC-V by 2030, is possible? So the first big change, you have the traditional architecture. And honestly speaking, if you have 20 up to 100 different ECUs, they have just a single function. It doesn't really matter if it's RISC-V, ARM, PowerPC, RX, whatever. It doesn't matter. But it's expensive. It's very difficult to maintain. It's, honestly speaking, a software nightmare. Yeah, as companies using still this architecture tend to have a big problem to update or upgrade their software. It's just a fact. Yeah, they are much slower. So all modern concepts we see today in cars are not using such an architecture. So from a computer perspective, it's just a better architecture to use a zonal high-performance compute architecture. So if you start from scratch and you think how a car EE architecture should look like, this is very likely what you would develop, design, and introduce as a baseline concept. Yeah, a zonal HPC architecture is simply the better architecture. Now, when you look at that, and if you map that to how this could look like with different architectures, the best architecture, of course, is something that would be open, that would be standardized, and so on. So, and guess what? We have one. The open, flexible, standard ISA is already there. Yeah, so it's our strong belief that RISC-V is the best option to implement such an architecture because you don't have architecture breaks. You can shift software from A to B without too much hassle. It's a much more simplified architecture overall, and you can generically move software wherever you want to have it. And that's especially important in automotive, because automotive requires scalability. Yeah, a Mercedes S-Class doesn't have the same EE architecture or cost structure like a Toyota Yaris. So RISC-V from our perspective is fundamentally the best choice to implement such an architecture. So in this scenario, we see that our approach is valid, that moving from the traditional, very fragmented world to the zonal, that's the best timing to switch from proprietary ISAs, which are maintained by individual companies, you're fully dependent on these companies, and move to RISC-V. So if this is possible, it's a kind of ideal scenario for everybody. For the automotive industry, because they have many suppliers. For the software people, because they can unify the code base. For the system architects, because they have a lot of different options to configure their system at the end. And it's for everybody just a positive thing. That's how we look at that. Now, is that possible with RISC-V? Is there something around that can be used? Is there a starting point? And we are basically saying yes. So from our perspective, RISC-V is more than mature enough to implement such a concept. Yeah, but of course, a couple of things still have to be done. But basically, all the starting points you need are there. So one thing, of course, is you need a company like Sci5 investing a lot into ASIL-B, ASIL-D, cybersecurity. We have seen the presentation from Andis this morning. They also have FUSA, functional safety-oriented devices, ASIL-B, ASIL-D. So this is not just a presentation about Sci5. We see competitors following a similar scheme. And this is important because also on RISC-V, and a major reason to move to RISC-V is the option of changing your supplier. You have many suppliers, and that's an important element. Nevertheless, functional safety is a difficult beast. We are managing it, so it's one of our key assets. One thing is, if you want to be by 2030 in the car and you only want to base it on RISC-V, you need a larger portfolio than what we have today. Now, Sci5 is having at this moment 3 IP cores in the market. One is in the entry segment, the real-time embedded one. This is going to be as safety islands in bigger SoCs on the street roughly by 27. There are other devices like the S7 and the E7, which are higher performance or move to 64-bit, also already released and going to be on the street in cars roughly by 26, 27. But then, and that's the important jump, the important step, we extend that portfolio on the one side to the very entry segment. You remember the zonal architecture, there are sensors and all these things. You need to have an entry-level device, an entry-level 10, 20K gate sensor CPU core, but then move straight up via various steps to the very high end, the ADAS, the infotainment cores, where we are delivering within 25, 26 high performance cores. All of these cores are today available as industrial or consumer segment devices. We are moving them now into automotive. And then for 2030, you have a portfolio that gives you the entire range from very entry to very high-end performance, so that you can cover the entire range. A couple of things still have to be done. We have many intense discussions in RISC-V International about real-time processing. There are a lot of special automotive requirements. We are working on that. We talk a lot about SIMD extension. So RISC-V International is having a lot of very intense discussion groups and working groups about vector extensions. They are very important to form the bridge or to build a bridge to AI and higher performance DSP architecture. So that's very important. And then, of course, we also need the ecosystem support in the very high end. Parts of that you have seen and probably heard already, which are done in the RISC initiative, where we are at the moment porting Android and others. So this is then giving you a basis so that the cars in 2030 can be built completely on RISC-V. So there is nothing we see at the moment which is missing that you cannot implement as ECU, as MCU, as SoC, as DSP, as AI, that you cannot build, you can all these things build with RISC-V. Yeah, that's the key statement, key message. And timing and ecosystem availability is fine for production in 2030. That's our key message. Yeah. So that means at the end, we see the vision coming true that by roughly 2030, there will be cars on the street which are all based on RISC-V. And I think that's all what the community hopes for. And that's especially, let me give you this reminder again, get your tickets at the counter for the raffle for very, very good gifts at 5 p.m. today. Thank you very much.